Socratic conference is an academic presentation that perfects the last stage of the Socratic method of study and Pareto principle rule. The mission of the Socratic conference is to make learners master the whole content. Rules. Socratic conference takes strictly 2 hours and 11 minutes. The first 15 minutes will be used by the Socratic 12. The first 15 minutes will be used by Kcador for conference orientation and message from DSLP Examination Center. The next 45 minutes will be used by the Socratic 12 to speak content. 50 minutes will be used by the Socratic memroom to ask questions. For those who are attending this program for the first time, anyone who is not presenting is in the memroom. So immediately they are done with presentations, you are expected to ask as many questions as you can. 15 minutes will be used by the teachers to make comments. The last 6 minutes will be used by Kcador to give for final remarks. Rule number 2, notes and textbooks are not allowed in the Socratic hall. Presenters and those asking questions must present or ask what has been mastered. No one is allowed to read questions from textbooks or research answers from anywhere. Silence is not just a rule, but it's a law. Students must observe meditative silence throughout the program. A student who will make noise will be excused from the conference and will not attend even the next conference. Communication is purely English. No shame. Of course, except in Kiswahili presentations when you can do Kiswahili. The 12 members must nominate 4 to 5 individuals who will do the actual presentation. The rest of the team will help in answering the questions. I know they know that. Presenters will not ask any questions or seek clarification from the memroom. Memroom will not be allowed to ask any questions. They are not allowed to ask presenters any questions while they are presenting. Those who ask questions must have answers for the questions that they ask. If no one answers your question, you are the one to provide the answer. That means all questions asked, you have to know the answer before you ask the question, because if no one answers a particular question, it will go back to, first of all, to the Socratic 12, secondly, to your school, and thirdly, to the rest of the school, the team, and finally, to the person who asked the question to give us the answers. Teachers are encouraged not to intervene or correct any students when they make mistakes. The mistakes can be noted and corrected during the presentation, after the presentation. However, if a teacher feels that an error presented demands urgent attention, then they are free to do so immediately. A student who asks a question must confirm whether the answer provided is correct or incorrect, or you are not satisfied. You are not satisfied when the answer provided is not clear. You are not satisfied when the answer is not complete. You are not satisfied when you don't understand what the other person is saying. Students are expected to have mastered or understood the question demand before they ask. Most of the time, we may require you to give the question context. And so it's important for you to ask questions that you understand. When asked to provide the question context, students are expected to ask the question again, provide the answer, and give further details related to the question. That means you speak more and say more about the same. Socratic conference is not a competition. It is not an academic contest. It is a platform to teach someone else. It is a platform to remove doubts. Actually, it's a platform for us to show that we have been in school all this time and we are ready for national examination. As we do all that, we humble ourselves following the Socratic footsteps. Socrates, the philosopher, who said, "The only thing I know is that I know nothing." We have come here to teach someone and to learn from someone, but with great humility. That is the point. Thank you so much. I want now to invite one student from, I believe, was it Sego Girls, who will give us some information. And I'm donating my Socratic, my minutes for the DSLP to the student who will speak something which I will get to know what. Thank you so much. Welcome.
Guests of honor, teachers, protocols observed, and my fellow students, good morning. As the epigram states that every dog has its day, today is mine. And before you is Charlene Achieng Owino, a student in Seko Girls High School. And I'm obliged at the epigram to say this obligation that today I am obliged to be given this obligation to talk about the role of sciences in our world today. First and foremost, I want to start by defining the word science. Science is the knowledge. Science is the knowledge about what's evolving around our world and the natural things based on what's evolving around our world. And first, let me start with biology. Biology has helped in career development, such as medicine, dentistry, and which we thank due to the involving of biology. Secondly, it's about the development of our bodies. We are able to know the changes which are occurring inside our bodies. And the second is about physics. Through the power of physics, we have seen improvements and inventions in our housing and roads, that nowadays our secondary roads don't look like roads in which battlefield bombs had been embodied in those battlefields, but due to the power and thanks to the power in which physics had been invented. Secondly, through physics, it's about the invention of power through the solar system, that everyone is able to access power. And as I wrap up, I want to say that if we students take a step of determination and perseverance, we are able to have a bright future. Simply because if Isaac Newton was able to invent the force of gravity, then it means that we students, we have a lot due to this curriculum. For that, I say thank you for giving me an opportunity. Thank you.
The rules. 1. You are provided with a pen and a Socratic whiteboard. Write all your answers on this board. 2. Listen carefully to each question. No question will be repeated. 3. You are not allowed to check what your friend has written. Do not turn your head until the end of the contest. 4. In case of a tiebreaker question will be given to determine the new winner. 5. All calculations are purely mental. You are not allowed to make calculations on the board or anywhere else. 6. You are not allowed to make any counting using your fingers. 8. Make sure you write your name. School and class. Relax and listen. Good luck. May the best contestant win. Question. A molecule or other species which can donate a proton or accept an electron pair in reactions. Question. Any chemical compound formed from the reaction of an acid with a base, with all or part of the hydrogen of the acid replaced by a metal or other cation. Question. Each of two or more compounds with the same formula but a different arrangement of atoms in the molecule and different properties. Question. A natural or synthetic man-made substance that when taken changes alter the body functioning. Question. A natural or synthetic man-made substance that when taken changes alter the abnormal body functioning to normal. Question. is a long and narrow, thin apparatus that widens at the middle, used to measure and transfer small, very accurate, exact volumes of a liquid solution. It is open on either ends. Question. Why is it that gases don't have definite shape? Question. List 4 sources of water. Question. Why are the elements of group 1 of periodic table known as alkali metal? Question. Draw a sketchy structure representing Charles's law. Stop.
We are going to begin with electrochemistry. First, you have to know what is electrochemistry and how does electrochemistry help us. So, the definition of electrochemistry is that electrochemistry is a branch of chemistry that deals with the relationship between electric currents and chemical reaction. In that way, we are going to study about redox reaction. Redox reaction is a reaction in which oxidation and reduction takes place simultaneously. Take for example, a reaction between iron and copper to sulfate. Iron is going to be oxidized and copper is going to be reduced. Also, we are going to study about oxidation number. Oxidation number, this is an apparent charge that an element has in a compound. Oxidation, now let's look at the rules of assigning oxidation number. The first rule is that oxidation number of a combined element is 0. Another rule is that the sum of oxidation number in a compound is equal to 0. Another one is that in a compound, oxidation number of hydrogen in all compounds is positive 1, except in metal hydrides, which is negative 1. Oxidation number also in oxygen in all compound is negative 2, except in peroxide, which is negative 1. Let's look about oxidation number. Let's talk more about oxidation number. Oxidation number helps us to determine whether this equation is a redox equation or not. It helps us to determine which element has been reduced and which element has been oxidized. We are going to study about, we are going to look about one equation of oxidation number. That is iron plus hydrogen peroxide. You add also a sulfuric 6 acid. In this equation, iron is going to be oxidized from positive 2 to positive 3. And oxygen is going to be reduced from negative 1 to negative 2. Let's talk about displacement reaction. Displacement reaction, this is a reaction where an element which is more reactive reduces a less reactive element in a reaction. For example, aluminium. Aluminium is more reactive than copper. So this aluminium will reduce copper from the solution of copper to sulfate. If you react this equation, you will get aluminium sulfate plus copper. This means that aluminium has reduced the sulfate from copper. Also, let's study about this displacement reaction. So this displacement reaction, can I have a marker pen? So here we see that aluminium has reduced the sulfate from copper into copper solid only. So this means that this aluminium is a reducing agent. Okay, let's study about standard electron potential. What is standard electron potential, and how does this standard electron potential help us? So the standard electron potential, we are going to look at the standard electrolyte. The standard electrolyte is hydrogen. Hydrogen being the reference electrode, it is given an electron potential of 0.00 volts. And also, hydrogen being a reference electron, hydrogen is going to be used to refer to other, you will know which element is oxidized and which element is reduced by use of hydrogen. Let's study about the electron potential difference. Electron potential difference, this is a difference in a cell, this difference in a cell of an element that comprises, this difference in a cell of an element that comprises of the 1 molar solution of its ions and also the hydrogen electrode. In this, we get to understand that this 1 molar solution is one of the rules in which we assign an electron potential to an element. The rules are, in assigning the electron potential to an element, you have to have a temperature of 25 degrees Celsius at of 1 atmosphere and a concentration of 1 molar per liter. 1 molar solution or 1 mole per liter. That is the concentration of it. Let's look at electrochemical cell. In an electrochemical cell, we are going to study the tendency of a metal to form electrons. The tendency of a metal to form electrons is the same as the ability of this metal to form electrons. So the ability of this metal to form electrons begins when a metal rod is dipped into a solution of its own ions. The outer atoms or the surface atoms of this metal rod emits electrons, and these electrons remains on the surface of this metal rod, and the metal rod develops a negative charge, and this negative charge attracts the electrons in the surface, attracts the electrons back. As this negative charge is built up, the ions emit electrons, and the more the rate of ions in emitting electrons until the rate at which ion gains electrons is equal to that rate at which ions emit electrons. This reaction is known as equilibrium. This is because the rate at which an atom emits electron is the same as that rate in which an ion gains electrons. So the reaction is equal. We are going to study about a dry cell. A dry cell is a primary cell. And what do I mean by saying that a dry cell is a primary cell? I mean that a dry cell cannot be recharged. We know that primary cells are the cells that cannot be recharged, while secondary cells can be recharged. In these dry cells, let's look at the function of some parts of the Leclanche cell, like the powder. What is the function of the powder in this cell? The function of the powder in this cell is that the powder increases the surface area it increases the surface area of the positive terminal. Let's look at the function of manganese 4 oxide. Then, what is this function of the manganese 4 oxide? Manganese 4 oxide acts as a depolarizer. When I mean depolarizer, what do I mean? I mean that this manganese 4 oxide is going to react with hydrogen to give us water. Finally, let's look at the fuel cell. What about the fuel cell? What is the fuel cell? Okay, fuel cell, this is an electrochemical cell that converts the chemical energy in a fuel directly to electrical energy. We also learned that this is an electrochemical cell that converts the chemical energy in a fuel directly to electrical energy. We also learned that this fuel cell is not, unlike the secondary cell, cannot store energy. I mean that this fuel cell does not store energy, but a secondary cell store energy. Thank you.
Okay, I'm Melan Chichir from DRICE, and I'll be taking you through electrolysis. With our basic knowledge from the Form 2, we learned that electrolysis, this is the process of decomposing an electrolyte by passing it through an electric current. As we are going to talk about electrolysis, there are some factors that affect this electrolysis, one of them being the position of an electrochemistry series. The other one is the nature of the electrolyte, and the third one is that the first one being the position in the electrochemistry, then the second one being the nature of the electrolyte. We are going to talk about electrolysis. We are going to consider we are going to consider some of the reactions. We'll be having the dilute sodium chloride as well as concentrated sodium chloride. The first reaction, when we talk about the dilute sodium chloride, here we are going to have the sodium chloride as the sodium ions, the chloride ions, the hydrogen ions, and the hydroxide ions. As you all know, we have the positive, which is the anode, and the negative, which is the cathode. We have the positive, which is the cathode, and the anode, which is the negative. So when sodium ions as well as the hydrogen ions, which are positively charged, they will move towards the cathode. Then the hydroxide ions and the chloride ions, they will move towards the anode. As we've said, the anode will have the chloride ions, the hydroxide ions. Okay, in the anode, where we have the hydroxide ions as well as the chloride ions, here, hydroxide ions are going to be preferentially discharged. This is because they have great tendency of losing electrons. The equation, so when they are discharged, the equation will produce water as well as oxygen gas. In the cathode, where we have the sodium ions as well as the hydrogen ions will be preferentially discharged. Hydrogen ions will be preferentially discharged to produce the hydrogen gas. We are going to consider now, this was the dilute sodium chloride. Now we are going to consider the concentrated sodium chloride. You find that in the anode, where the hydroxide ions were preferentially discharged, now the chloride ions will be preferentially discharged. This is because they have higher concentration. And then in the anode, we will be having the sodium ions as well as the hydrogen ions. The hydrogen ions will be preferentially discharged. Despite being sodium having the higher concentration, they will have the overpotential. We are going to consider the nature of the electrode. In the nature of electrode, we will be talking about the copper electrode as well as the carbon or the platinized platinum. When we talk of the copper electrode, we are going to consider the solution of copper 2 sulfate. Here, the copper 2 sulfate will be having the copper ions and the copper ions, the sulfate ions, the hydroxide ions, as well as the hydrogen ions. The copper, which are the positively charged, as well as the hydrogen ions, will move towards the anode. Then the sulfate ions, as well as the hydroxide ions, will move to the. Then for the sulfate ions as well as the hydroxide ions, for that case, the hydroxide ions will be preferentially discharged, and the equation will still remain the same. In the case of the cathode, now the copper 2 sulfate as well as the hydrogen ions, we find that hydrogen ions will be preferentially discharged. Thank you.
My name is Purity. I'm going to take you through the applications of electrolysis. There are some applications of electrolysis, and one of them is electroplating and the manufacture of sodium hydroxide. So we are going to majorly look at the manufacture of sodium hydroxide. So in the manufacture of sodium hydroxide, we will, I'm going to state how it works. So when an electric current is made to pass through sodium chloride solution. Sodium chloride solution contains sodium ions, hydroxide ions, hydrogen ions, and chloride ions. So in the process, the chloride ions and the hydroxide ions will move to the anode, where the chloride ions will be preferentially discharged. This is because the chloride ions are more concentrated. And then as a cathode, there is sodium ions and the hydrogen ions. So the sodium ions will be preferentially discharged. This is because the hydrogen ions will not be discharged, maybe because they require more energy. Yeah. So when the sodium ions are preferentially discharged, they will react with the mercury. In that, there is a process. They will react with the mercury, forming sodium amalgam. So this sodium amalgam will be passed through a container, a trough containing distilled water. So when it will react with distilled water, it will form sodium hydroxide, mercury, and hydrogen. And that's how we will get sodium hydroxide. So in this case, mercury is recycled simply because mercury is poisonous and it is expensive. And then, that's about the manufacture of sodium hydroxide. Okay, I'm going to take you through this. When you want to determine the mass of an element, this is the process, this is the formula. Mass, let me just say, mass is equals to RFM multiplied by the quantity of charge all over the column times 96,500. 96,500 is the 1 mole of Faraday. Yeah, that's all. Thank you.
Good morning. I'm Rahab, and I'm going to take you through carbon and its compound. And to start it off, allotropy is the existence of an element in more than one form in the same physical state. And there, talking about carbon, it has two allotropes, that is graphite and diamond. To start with the diamond, it is a shiny elastic. It is a shiny with a crystalline solid, and its physical properties are it has a high density. It also has a high melting point. It is a hard substance. To the graphite, adding to the diamond, it does not conduct electricity. And for the graphite, it conducts electricity because its 3 carbon atoms form the covalent bonds, but only one is delocalized, which is responsible for the conduction of electricity and heat. It has a low density. It also has high and low melting point. It has high boiling and melting points. Properties of carbon. Carbon reacts with oxygen with a red glow, and it forms a colorless gas which reacts with calcium hydroxide to form a white precipitate. It also reacts with sodium hydroxide. It also reacts with the copper metals. For example, when we react the copper 2 oxide, which is brown, it is being reduced to a brown metal of copper and a colorless gas, which is carbon 4 oxide. It also reacts with the dilute acids such as nitric 5 acid and dilute sulfuric 6 acid to form respective gases such that is nitrogen 4 oxide, which is a brown gas, and also sulfur 4 oxide gas, and carbon 4 oxide and water respectively. For the reaction to occur, this is because the acids are oxidizing agents while the carbon is a reducing agent. I'm going to talk about carbon 4 oxide, which is an oxide of the carbon. Carbon 4 oxide is prepared by reacting calcium carbonate with hydrochloric acid to form calcium chloride, carbon 4 oxide, and water. to dry the gas or to obtain the carbon dioxide while dry, you pass through it with a dehydrating agent, which is a dilute sulfuric acid. There we are going to see the physical properties of carbon dioxide. It is odorless, it is colorless, it is highly poisonous, and it is denser than air. The chemical properties of carbon dioxide. Carbon dioxide dissolves in water to form a carbonic acid. It also reacts with sodium hydroxide to form sodium carbonate, and in excess carbon dioxide, it dissolves to form sodium hydrogen carbonate. Carbon dioxide also reacts with calcium hydroxide to form a white precipitate, that is calcium carbonate, and in excess carbon dioxide, it dissolves to form a colorless solution of calcium hydrogen carbonate. And it also, as we see also, we are going to see the uses of carbon dioxide respectively. It is used as a fire extinguisher. It is also used as a refrigerating agent. It is used when dissolved in water, it is used to make aerated drinks, and it is used in making baking powder. For the carbon dioxide, also an oxide of carbon, there are 3 ways in which you can prepare carbon dioxide. One is by dehydrating ethanoic acid with diluted sulfuric acid to obtain carbon dioxide and water. The second method is by dehydrating ethanedioic acid, mark it, ethanedioic acid with dilute sulfuric acid to obtain carbon dioxide, and water respectively. And because we have the formation of carbon dioxide, you have to pass the solution through sodium hydroxide so that it will remove carbon dioxide. And the third method is by passing carbon dioxide through heated carbon to obtain carbon dioxide. The physical properties of carbon dioxide: it is odorless gas, it is a colorless gas, and also it is highly poisonous than carbon dioxide. This is because it reacts with hemoglobin in the blood to form a stable compound, which is carboxyhemoglobin, which deprives oxygen from their bodies. And that's all about it.
Good morning. My name is Naomi. I'm going to take you through carbonates. First, action of heat on carbonates. We have the group 1 elements, that's sodium and potassium. So sodium and potassium carbonates does not decompose. This is because they are stable, except ammonium carbonate. Also, you all know that all sorts of ammonia decompose on heating. The likes of magnesium, zinc, iron, they decompose to produce carbon dioxide and metal oxide and carbon dioxide. The reaction of carbonates with acids. We have the reaction of, for example, magnesium carbonate with dilute hydrochloric acid. It will give you metal oxide plus carbon dioxide plus water. We go directly to the Solvay process. First, before we go to the Solvay process, we have the extraction of sodium chloride from seawater. So first you pump the seawater through shallow basins, then allow evaporation to take place, then obtain the crystals of sodium chloride. The Solvay process. In the Solvay process, we have the raw materials. We have the coke, that's calcium carbonate, or you may call it limestone, yeah. And we have also ammonia. We have brine, that's concentrated sodium chloride. So in the Solvay process, we have ammonia. We have brine, that's sodium chloride. So when you react this one, it will give you ammonical brine. So then it goes to the carbonator. So in this side, we have coke, that's calcium. We have limestone, that's calcium carbonate. So there is, in this case, we have the calcium carbonate. We decompose it. It gives us calcium oxide, that's lime, and carbon 4 oxide. So the carbon 4 oxide will go to the carbonator. Then calcium oxide, that's lime. It will go to the slacker. So in the slacker, we have distilled water. It will react with this lime calcium oxide to produce calcium hydroxide. So the equations at the carbonator, we have two equations. So it is ammonia plus water plus carbon 4 oxide. It gives you ammonium hydrogen carbonate. Ammonium hydrogen carbonate will react with sodium chloride, that's brine, to produce ammonium chloride and sodium hydrogen carbonate. So we have the sodium hydrogen carbonate. And ammonium chloride. So before this, we distill it. So ammonium chloride will be the filtrate, then sodium hydrogen carbonate is the residue. So the residue, it will be heated to produce sodium carbonate and carbon 4 oxide. So the sodium carbonate, you have produced sodium carbonate, then carbon 4 oxide is recycled. So after distilling it, you obtain ammonium chloride as the filtrate. Then ammonium chloride will react with the calcium hydroxide from the slacker. It gives you calcium chloride plus ammonia plus water. So ammonia, as you all know that ammonia is the raw material, we will recycle it. So the process will be economical. So you will recycle ammonia here. After it reacts with the calcium hydroxide, it will produce calcium chloride, ammonia, and water. So the ammonia will go to the Solvay tower. It will react with brine. So the calcium chloride is not recycled because it's not our raw material. So we find that Solvay process is economical because in this process we recycle most of the raw materials. That's carbon 4 oxide, water, and ammonia. We have the uses of calcium chloride. Anhydrous calcium chloride is used in the laboratory to dry gases, and also it's used in moistening rods because of their deliquescent nature. We have sodium hydrogen carbonate. It's used in the manufacture of health drinks, and also it's used in the manufacture of health drinks. Then uses of sodium carbonate, it's used in softening water, and also it's used in the manufacture of sodium silicate, which is used in the manufacture of detergents. That's all.
Well, thank you so much for that. Straight away, we move to the questions. And now, I hope we have, how many microphones do we have? So, yes, you raise your hand, you ask your question, then we begin. Questions. Now it's question time. Question time. Anyone from the group, anyone from the team can ask a question, except, of course, priority goes to the other schools, except the schools that presented. So we begin. Questions. And then I have the microphone. Questions. We begin the questions now. Yes, thank you.
My name is Naomi from St. George's Girls Eldoret, and I have a question to the member of the Socratics. Name for me the name of the energy that is used to manipulate carbon into its allotropes. Yes.
Yes, let's have an answer for that question. Can you do it again? And of course.
Yeah, it's correct.
It's correct. Thank you so much. Next question. Next question. Please come. Help me so that we can move the microphone very quickly. Please, question. Raise your hand. Question. Next question. Question. Let's move very quickly. Question from the other side.
My question is, why is carbon dioxide used as a fire extinguisher?
Let's have an answer for that question. Let's have an answer.
Because carbon dioxide is denser than air, therefore it forms a blanket, cut off the supply of air.
To find out whether it's correct or incorrect, or you are not satisfied.
I'm not satisfied because I've asked that.
Okay, so you are not satisfied. Thank you so much. Let's find out from the person who asked the question. Do you insist that that is the correct answer?
Yeah, that's the correct answer.
Yes, anyone from the team can, let's find out whether, yes, let's have someone else to say something.
Okay, my colleague messed by saying carbon dioxide, which is supposed to be carbon dioxide, but his answer is completely correct.
Thank you so much. Yes, we find out whether anyone is not, has a different opinion. Is that, are we satisfied with that? Satisfied? Anyone with a different opinion or something to say? Then thank you so much. Next question. Next question. Next question. Please, keep coming. Just give you a very far, please come. So that we don't waste so much time. Yes. And silence.
My name is Kcador. Here goes my question. Describe an experiment to distinguish, to prove that diamond and graphite are allotropes of carbon.
Thank you so much. Let's have a question, an answer for that. An answer for that question, very quickly. Yes, very quickly, let's have an answer for that. I'll come to you if you want to give an answer. Let's give the Socratic 12 to give an answer for that. And if you have no idea, then I'll give it back. If there is no idea, anyone? Yes, somebody here? Yes? Looks like they are not ready to answer the question. Members from their schools, Dries Girls and AIC Kesub Girls. Now, you are here to defend. You are defense team. Now the defense team, let's find out whether you have an answer for this. Dries, the rest of the members? Looks like there is no one. Anyone from the team can give an answer. Anyone except St. Patrick's High School. Anyone? Yes, please. Can you give us an answer? Yes.
Thank you very much. The experiment, if you burn carbon, any carbon in air, it can be able to release water and carbon dioxide. And if you want to test that carbon dioxide, you use calcium hydroxide or any other hydroxide. That is the answer.
Is correct, incorrect, or you are not satisfied? Not satisfied. So thank you so much. Anyone? Yes, we have someone here. Yes, please. Let's have your answer.
I think you'll use graphite and diamond as electrodes, and a bulb should be there so that it can confirm if graphite and diamonds will conduct the electricity so that the bulb will light.
To find out whether it is correct, incorrect, or not satisfied, there are only three options. You only give me correct, incorrect, or not satisfied. It's correct. Now, thank you so much. I will want you to give me the question context. Question context. Coming back to you, give me the question context. Question, rise, please. Question context means the question the answer and more details. Question, the answer, more details. Please.
To repeat my question, I asked, describe an experiment to distinguish, to prove that graphite and diamond are allotropes of carbon. So, to start, carbon has four electrons in its outermost energy level, isn't it? So, graphite uses three of its electrons to form bonds, while diamond uses all of its electrons, the four of them, to make bonds. So so this means that graphite has an extra delocalized electrons, which conducts electricity. So when both of them are used as electrodes, graphite will allow current to pass through since it contains that delocalized electron, while diamond has none. So in this situation, we get to know that both of them are allotropes of carbon, because one used three of its electrons to form bonds, while the other one, which is diamond, used.
Well, thank you so much. Unless again you have something different to say, anytime an answer is given, you are not satisfied, even with the person who asked the question, you need to raise your hand. Thank you so much. Let's move to the next question. You have something to say, or you want to ask a question, or you have a different opinion. Just give me the microphone.
Yes, I want to ask, are you differentiating between graphite and diamond, or you are proving if it's a metal carbon?
Yes, I was also wondering, but anyway, you need to speak.
Yes, because I think your answer, you are differentiating between diamond and graphite, but you're not proving that it is an allotrope of carbon.
Well, did you prove to us? Can you please be very concise and precise? Please. Yes, please. Very quickly. Oh, microphone.
Okay, so yes. So theoretically, we know that carbon has two allotropes.
What was your question? What was your question? Straight to the answer.
Describe an experiment to prove that graphite and diamond are allotropes of carbon. So theoretically, we know that carbon has got two allotropes, which are graphite and diamond. And graphite has got one delocalized electron because it used three of its electrons to form bonds. But diamond uses all of the four electrons. So when these allotropes are used as electrodes at let's say in a circuit, So graphite will conduct electricity because it has that single electron which acts as a delocalized electron used to conduct electricity, but diamond has none. So if there was a bulb there in the circuit, the bulb will light when graphite is used, but diamond will not light but the bulb will not light when diamond is used, meaning that both of them are allotropes of carbon.
Well, I don't know whether, yes.
My friend, that is differentiating. That's differentiating. In fact, you're differentiating between the electrical conductivity between graphite and diamond, but you're not proving. Even the element number 4 does not conduct electricity unless you use the optimum temperatures or the conditions.
Do you mind giving us an answer according to you?
For me, I've never seen anything like proving that is. Yeah, for me, I've never.
Well,
seen
someone has something to say.
Unless
Someone
they
has
have an
something to say.
answer.
Thank you.
My name is Wilan Kiplimo, and I'll prove that answer, that question. Okay. When you burn diamond, it will produce. Okay, diamond and graphite has different. Diamond and graphite has different boiling points and melting points. So when you burn diamond, you'll get carbon dioxide, which will prove it is carbon dioxide when you pass it through sodium in lime water to form a white precipitate. And when you burn graphite, it will also produce carbon dioxide, which is proved to be carbon dioxide when you pass it through lime water. Thank you.
I am not comfortable with you because you speak like you didn't take breakfast. So please, when you speak, speak well, okay? And use the microphone very well, okay? Yes, I would, yes. You still want to say something? Okay, thank you so much. Yes. Anyone with a different, yes, please. Yes, yes, please, yes.
So for me, I think that he was right because he differentiated it using the circuits, and then the circuit light.
Yes, someone here.
Okay, so I think under that, his answer he said that he was differentiating between graphite and diamond. But I think the answer he said that when you burn diamond, it will produce carbon dioxide and water. And also when you burn graphite, it will produce also carbon dioxide. That when you pass it through calcium hydroxide, when you pass it through freshly prepared calcium hydroxide, it will form white precipitates. And so that you'll find that both of them produces carbon dioxide, which when passed through freshly prepared calcium hydroxide, it will form white precipitate. Thank you.
Unless you had something different to say, I should be moving to the next question. Yes, you had something to say on the same.
Very quickly. Okay, you asked about the experiment, but I think you gave out the answer for a differentiation. Distinguishing between the carbon.
I will, yes, something different or the same?
On my opinion about the question is that both diamond and graphite, for it to be allotropes of carbon, when you see on their structures, they both are bonded to carbon atoms. So that's why I think we say that the diamond and graphite are allotropes of carbon because they are bonded to carbon atoms.
Looks like this question is giving us some challenge. Yes, please. Yes.
My name is J Cube. So to answer his question, he asked describe. So you just say describe an experiment to prove that, yeah. So you say that you burn both diamond and graphite separately in air, and the gas produced, you bubble it in you bubble it in calcium hydroxide, a white precipitate will be formed. So then you go further to explain that this white precipitate is calcium carbonate, and it confirms the presence of calcium dioxide. So as you know, when carbon is burnt in air, it produces carbon dioxide. So that one proves that both are allotropes of carbon.
Yeah, thank you so much. In case there are any other clarifications, teachers are listening. They will speak to us later. Next question. Next question. Next question.
So, okay, my question also comes from carbon and its compounds. Why is it that graphite is used as writing, in writing?
Is that question very clear? Well, let's find out from the Socratic membrum, 12, the Socratic 12. Give us an answer for that if you got the question right. Yes. An answer for that?
This is because
What is the question?
why graphite is used in writing.
In writing. That is how the question is supposed to be? Oh, thank you so much. Yes, go ahead.
This is because the hexagonal layers of graphite are held by weak van der Waals forces, which can easily slide over each other when pressed.
How is it used in writing? Just be a bit. How is it used in writing? Well, is that the answer you wanted? Is that clear? Is everyone okay? Let's move to the next question. Next question. Next question. It's not this team, not this one. Next question from here. Next question from there. Please, do you have the microphone there? Move it.
Okay, thank you. My name is Boniface. And just to ask, still on carbon and its compounds. Boniface?
Okay, so let me ask you. If we react a cation of copper and an anion of hydrogen carbonate, what will be the product?
Let's have an answer for that question. Let's have an answer for that question. Did you get the question clear? Please, can you do it again?
If you react, an ionic equation with a cation of copper and an ion of hydrogen carbonate, then what will be the product of the reaction?
Yes, let's have an answer for that. Let's have an answer for that. The Socratic 12. Yes? What?
I think the answer is that the products are copper carbonate, carbon dioxide, and water.
Let's find out whether that is correct or incorrect. Incorrect. So another person can give us an answer. Anyone else? Yes.
I think it's copper 2 oxide, carbon 4 oxide, and water.
Yes.
Incorrect.
Incorrect. Yes.
Copper hydroxide.
Looks like you are not satisfied?
No.
Yes, please.
It will not react because copper is below hydrogen in the reactivity theories.
Not yet.
Let's have now anyone from the membrum. Anyone from the membrum. Except the two schools. Anyone. Or anyone, including the schools. Let's have anyone to raise hand and give the answer. Looks like there is no one. St. Patrick's High School. Anyone from the Saints? Anyone? 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 Okay, someone wants to give an answer here.
So it is a
reaction between the cathode of copper and an ion of hydrogen, yes? So the answer will be copper solid and hydrogen ions.
Looks like the young man is not satisfied. I still ask the St. Patrick's High School, anyone from the team, anyone? Anyone? Unless you want to tell me it's the only one who knows. Yes. Anyone? Yes? No. No one? No one? Yes, we have someone here.
I think the reaction will come to copper carbonate, water, and carbon dioxide.
Not correct. Now, let's have answer from the author of the question. Let's have an answer and question context.
Here is it.
What is the question?
The question was, when we react an ion of copper and a cation of hydrogen carbonate, what will be the product? She was right, but didn't satisfy me. There's no reaction. So this is because there are only 5 hydrogen carbonates. That is sodium, potassium, ammonium, magnesium, and calcium, of which calcium and magnesium are in solid form, and potassium, sodium, and ammonium are in solid form. But in the question context, yes, they are above hydrogen in the reactivity series. Thank you.
Thank you so much. Thank you so much. Of course, if you don't agree with him, you always have the right to raise your hand. If you don't agree with him, you can always raise your hand. Next question. Next question. Show him how to. Yes.
So, to answer his question, carbonates are formed from their respective hydrogen carbonates. And potassium hydrogen carbonate is more soluble at low temperatures. So let's say, for example, when you refer to the manufacture of sodium carbonate in the Solvay process. So potassium hydrogen carbonate must be first crystallized out. So because of its high solubility in the solution, it will not crystallize out to form potassium hydrogen carbonate crystals. So therefore, it is therefore difficult to prepare it.
Well, just quickly, just let me know whether you are satisfied or not. You are. I would just want to request that this question is given, an answer is given in your own words, in your own way. Please, let's have the microphone here. Let's have the microphone. Just very quickly, can we give us question and answer?
Okay, the question was, why is it not possible to manufacture potassium carbonate in the same way as sodium carbonate? So, as we all know, potassium hydrogen carbonate is more soluble at low temperatures, unlike sodium hydrogen carbonate. And as you have said, carbonates of sodium and potassium are manufactured from their respective hydrogen carbonate. However, during the Solvay process, the ammonium chloride formed, and in the case of potassium carbonate, ammonium chloride formed and potassium hydrogen carbonate formed has to be separated using a fractional crystallization. And this is not possible because potassium hydrogen carbonate is more soluble at lower temperatures. So there will be no way of separation, and you will not get what you intended to get. Thank you.
Well, thank you so much. We move to the next question. Next question. Where is that microphone, please? Next question from this side. Let's have a question from here.
I have a question from carbon and its compound. Why is carbon 4 oxide considered as acidic? Yet, why is carbon 4 oxide considered as acidic and yet it does not contain the hydrogen ions?
Let's have an answer for that question now. Let's have an answer for that question. Socratic 12. Yes.
I think that it will react with water to form a weak carbonic acid. It will react with water to form a weak carbonic acid.
The question is why?
Why is it that carbon?
Did you get the question? It was?
Why is it carbon 4?
Use your microphone, please.
Why is it carbon 4 oxide is referred to as an acid?
You didn't get the question right. So, please, just come over. Let's just come so that, yes. What was the question?
My question was, why is carbon 4 oxide considered as acidic and yet it does not contain hydrogen ions?
Please, quickly now. You got the question right?
I think carbon 4 oxide would react with water to form a weak carbonic acid.
Looks like that is not correct. Looks like that is not what she wanted. Let's have anyone else from the team. Yes, please. Someone answering the question.
When carbon 4 oxide is exposed to air, it forms a weak carbonic acid.
Not correct. Anyone else? Anyone else? Any other student? Any other student? Any other one? Anyone else? Yes? Someone wants to answer the question, please. Yes.
So my name is Ian. And the answer is this because oxides of nonmetals are acidic.
Find out whether that is what you wanted. Not satisfied? Not yet. Yes, someone here. Yes?
I'm called Kelvin, and the answer is carbon 4 oxide dissolves in water to form a weak carbonic acid which contains hydrogen ions that gives an acid its properties.
Find out whether that is correct. Incorrect. Let's find out another student. Anyone else? Yes, there is a girl there. There is a girl there from Dries. Please, let's have an answer from you.
The reason being is because an acid is a substance that reacts with a base to form water and a salt. So when you react calcium hydroxide with CO2, you'll obtain calcium carbonate and water. Yes.
Yes, not satisfied. The man holding the microphone is not agreeing with you. Can you tell us why you don't agree with her? The man you are... Yes, please tell us. Holding the microphone, tell us why you don't agree with her. You were shaking your head like that and you didn't agree with her. Tell us, speak your mind. Speak your mind. Because your role is not just to carry the microphone. I know you have something to say. Well, thank you so much. The person with the question, is it correct? Incorrect? Tell us something.
Well, Kelvin was right, but I wanted him to complete the answer because an answer can never be complete until it's complete. So I wanted him to say that it turns blue litmus paper to red.
So give us the complete answer now. Relax. Complete answer. Let us have the answer complete. Complete the answer now.
Okay.
What is the answer?
The answer is that carbon dioxide, when it dissolves in water, forms the weak carbonic acid, which also contains the hydrogen ions. And we know that an acid is a substance that dissociates fully or partially in water to produce hydrogen ions. So Kelvin was right, but I wanted him to complete the answer.
Thank you so much.
Jambo tena. My name is Ruto, once more. Allow me to begin by congratulating the presenters for a job well done. Good work. We like the work that has gone into getting us the presentation you've done today. Secondly, a number of issues have come up from the presentation, which I would want to say, maybe highlight. And, one of them is the depth of or the coverage of the areas we were to work on. I have a feeling we were too much on the surface, particularly on electrochemistry, and a number of areas were not actually covered. In spite of the short time, I don't think electrochemistry can be complete without us doing a calculation or two. We have calculations on E-values. We also have calculations on the quantitative aspects of electrolysis. So I think that should have come out more strongly. Our first presenter, I think mentioned something on reducing the sulfate. That was a reaction between aluminium and copper 2 sulfate. It's actually a reduction oxidation reaction between aluminium and copper, not the sulfate. That's one of the things that came up that I noted. Under the applications of electrolysis, that should have been the second presenter. The reason as to why sodium ions are preferentially discharged over hydrogen also did not come out clearly. And I think this is one of the areas in which the type of electrode you use, as well as the energies involved, plays a role. In the flowing mercury cathode cell, the cathode is mercury. So that plays a role, ensuring that you need a lot more energy to discharge hydrogen as opposed to sodium. That's why you're able to get the sodium. In the Solvay process, separating sodium hydrogen carbonate from ammonium chloride is not distillation. That should be filtration. I think is a correction that should come out. And maybe for this last part, the reason why we are getting a low amount of chlorine compared to hydrogen. When you write the equation, the ratio is 1:1. So you expect an equal volume of hydrogen, gas, and chlorine. The solubilities are different. The electrolysis is happening in a solution, and you definitely have water in there. Chlorine is more soluble. Hydrogen is almost insoluble, and you would expect that some of the chlorine will dissolve in the water. You would also have a variation of that question about, maybe you'd want to look at that, a mix of gases in electrolyzing sodium chloride, whether dilute or concentrated. And there would be, I think at one point, production of oxygen, then chlorine, and then maybe chlorine, and then oxygen. Others, I'd want to thank all of us. I think I've also learned a thing or two from the research you've done. That means you're doing a lot of reading. I also have liked the criticality, the critiquing that has gone into the kind of questions we have presented. Particularly the one on allotropes of carbon, diamond, and graphite. So I think we're not just here to just accept answers. We should be able to look at it critically and find an answer at the end of the day. Thank you very much. My colleagues.
Good afternoon. My name is Mr. To from AIC Kesub Girls, and there is only one observation I made. From our bench here, we realized that most of us were comfortable asking questions on carbon and its compounds, meaning we are conversant. That would also tell us that more work needs to be done on electrochemistry. Most of us here, we asked questions on carbon and its compounds, and we left electrochemistry. Secondly, the presenters who are presenting, the Socrates 12. Next time you are presenting, you need not just to give us the areas given on KLB. We were going in an order that is sequential, moving from one subtopic and that's the same subtopic, meaning we did not go beyond our KLB books. And on the issues of calculation, some of the presenters were giving out formulas on how to calculate maybe mass, but if you want to get marks or to be more conversant on the same, just do it sequentially. Mass deposited, Faraday's law, so that your work is sequential. Lastly, when we are naming ions, someone is saying copper ions. Most of these ions in transition metal elements have got more than one oxidation state. So next time you are mentioning an ion, just give its oxidation number. It's always more confident you say copper 2 ions, ion 2 or ion 3. And lastly, on electrolysis, when you're giving us the ions, sometimes it's even better when you give us the source. Maybe sodium chloride, dilute, you say sodium ion from sodium ion, chloride ion from the electrolyte, hydrogen ion, hydroxide ion from the solvent. Otherwise, we have learned so much from you. You know a lot of chemistry. What is only lacking is how to put the same chemistry that you have into correct answers to earn new marks. Thank you very much.
Thank you. Thank you, the presenters and the panelists. I wouldn't have wished to say so much because we are the hosts. I would have given so much time to the guests, but I want to mention 4 areas from the discussions that have ensued. And first, to thank the presenters for making such a wonderful presentation, and those people who also participated in giving the questions and giving the answers. I think the whole discussion has been wonderful. However, I would like to point out 4 areas from the discussions that have come up. Number 1 is on questions that deal with confirmatory aspects. Most students make mistakes in those areas. You are asked to confirm maybe the chemical aspects or the physical aspects of a compound, and you end up describing something that may not give the correct answer. My advice is, please narrow down to the specifics of that question. If you are confirming a chemical, you are confirming a particular aspect about chemistry, then it is precise. Sometimes the confirmation can either be physical aspects or the chemical aspects. So you need to really work on that. We were listening to the way you are trying to give those confirmatory aspects, and it's still wanting. So you need to check on that one there. The other issues on description, questions, especially those ones that deal with the descriptions. Well, when you are giving your presentations here, we would not gauge whether you are trying to explain them in form of paragraphs or in form of points. But my advice is, especially when it comes to theory aspects, questions on description must be given in point form. As much as possible, avoid giving them in paragraphs. And when you are describing the areas that you are giving, look at the marks of the question. If the question is 2 marks, endeavor to give 4 points. If the question is 3 marks, endeavor to give 6 points. Each point in description will earn you half a mark. So the number of points you are going to give will be determined by the marks of that question. The other area is on differentiating concepts. And this is now a common question in chemistry, especially paper 1, where you are asked to differentiate various aspects. Like you are trying to differentiate between water gas and producer gas. So be very precise, because you are only looking at the constituents of the two mixtures. Sometimes you are asked about maybe differentiating between SO2 and chlorine, maybe with respect to bleaching. So those questions are quite common, and you really need to narrow down to them. Lastly, for each area that you are presenting, if it is carbon and its compounds, it has got specific objectives. If it is electrochemistry, it has got specific objectives. Now, when you master those objectives, whether they are 7, they are 8, they are 11, or whatever, you will realize that each objective is attached to a diagram or attached to an illustration, especially when you are using KLB. And my advice is stick to KLB, because that is where the KCSE questions will be asked from, and that is where we will make the marking scheme from. Sometimes we put aside all these other revision texts. So you need to check on those ones there. So every objective has a diagram or has an illustration attached to that objective, so that when you are thinking of an objective, you are thinking of that diagram. Most of the times you come across questions that have got a lot of setups, a lot of diagrams, and a lot of illustrations. It must guide you that it is leading you to a particular objective. If you put aside the objectives, it will be very difficult for you to comprehend the concepts of a topic. Otherwise, Daktari, this is a wonderful session, and I want to really thank the participants for the great work they have shown. Thank you so much.
Thank you so much. Want to also appreciate again the teachers for the good work they have done. Please take note of what they have told you. I know there are no notebooks and we don't have pens here, but I know you get it clear, because we've said that it is the last lap. This is the last lap. And we are also saying that it is the time to speak things by the right name. This is the time to speak things by the right name, because very soon we are expecting to write an exam. I want to thank the presenters for the good work they've done. There is evidence that they read, and they met, and they prepared. There is evidence that they prepared for this presentation, and they were here for the same. I want to thank you, except of course the areas which the teachers have said. Please take note and go back to school and read. I've always said that there is no magic that takes place in the Socratic conference. Magic takes place while you are preparing, while you are studying in class. That is the time for magic. You just come here and actualize what you prepared. So I'm happy if we continue doing this every other time and do so many conferences. Personally, I have seen so many students before you who have had very good grades because of such a method. So I want you to practice even when the Kcador is not there in your schools. Please continue to present and present and present. As we say the formula, read, understand, and present. You read, understand, and present. So thank you so much, presenters. Today we had several questions from the different groups. I want to appreciate those who asked questions. I'm only saying that most of the questions were knowledge, comprehension, and maybe some application, and few maybe was beyond that. But I would want us to, next time, I will expect that in the biology conference, let us move to synthesis evaluation questions, because that is now the nature of the questions that were asked in the Socratic conference. I loved some of the questions which are very challenging. I loved that some questions went back to the person who asked the question. I love the fact that some of us engaged and had what you call a very serious engagement in Socratic exchange, or Socratic exchange. So I like that. I would just want us to not to be very generous in accepting an answer, unless when it is really clear and it is very well explained. Don't be very generous. You will always need to critically analyze and listen so that you can provide the answer as is stated, as is asked. And also I want us to please research before we ask our questions. Let us make sure that we've done enough research and we know the answer for the questions asked. Because sometimes we are asked to give question context and you realize that it is not sufficient, there is no sufficient information. That was good and I loved it. I would want to say in the chemistry conference, the objectives of the Socratic conference were achieved. Next time we have another one, please let us even prepare more.